All right, so we have what I think is the hardest problem in the group. We have puppet makers. We have 5 puppet makers, and they're all working together. And together, they take 3 days to make 6 puppets. So that means we really would need to figure out is how many puppets per day they make. And then we're going to figure that out. And once we do, we need to figure out how long it takes one puppet maker to make 4 puppets. So, first thing, we need to find the puppets. P stands for puppets per day. And the word per means divide. So when we have puppets per day, we're just dividing the number of puppets by the number of days. So how many puppets did we make with the 5? We made 6 puppets in 2 days, which means we made 3 puppets per day. So, oh my goodness gracious. That should be a 3, not a 2. 6 divided by 3 is 2 puppets per day. All right. Now, it stands to reason that 5 puppet makers can work 5 times as fast, right? So that means if 5 puppet makers can make 2 puppets in 1 day, then 1 puppet maker would have to take 5 times as long. So that means to make those 2 puppets, it's going to take 5 days. So for 1 worker, it's going to be 5 days to 2 puppets. Well, wait a second. We want to know how long it's going to take to make 4 puppets. What's the relationship between 2 puppets and 4 puppets? It's twice as big. Well, if it takes 5 days to make 2 puppets, then how long will it take 4 puppets? It's going to take 10 days. My board is really unhappy. It needs this long weekend. All right, and that's my answer, 10 days. Now this made it seem a lot easier than it was. To be honest with you, I flubbed it a couple times. All right, number 17. When it erases, number 17. Okay, the value of 7 squared is 49 because 7 squared means 7 times 7. Similarly, the value of 5 to the third is 125 because 5 to the third means 5 times 5 times 5. And the value of 3 to the fourth is 81 because 3 to the fourth means 3 times 3 times 3 times 3. So what is the ones digit of 2012 to the 5th? Now, your first inclination is going to say do 2012 times 2012 times 2012. We're going to do that 5 times, right? But that would take bloody forever, wouldn't it? Yes, we don't want to do that. So let's take a closer look, oh, I don't know, at the number 2 to the 5th. So 2 to the 5th is equal to 2 times 2 times 2 times 2 times 2, which is equal to 32. And this is the ones digit. Incidentally, that's going to be the answer. The interesting thing here is, let's take a look at this one. When you have 5 to the 5th, 5 times 5 is equal to 25. And then to get the next ones digit, you're just going to end up multiplying the original number by the ones digit again. So it doesn't matter if it's 2012. The ones digit is always going to, in this situation, it's always going to be this first digit to whatever power. Now the interesting thing about this is, I mean, and obviously 2 to the 5th isn't too bad. You can go through it really quickly, but I want to take a look at a bigger problem so that conceptually we have a chance of getting things that are a little bit harder. Let's take 2 to the x power. In other words, we're going to take 2 to several different powers. 2 to the first power is just 2, right? 2 to the second power is equal to 2 times 2, which is equal to 4. Putting my 2 from up here. 2 to the third is equal to 2 times 2 times 2, which is equal to 8. 2 to the 4th is equal to 2 times 2 times 2 times 2, which is equal to 16, but I only care about the units digit. I only care about the units digit. So I'm going to put a 1 here, but really we only care about the 6. 2 to the 5th, we've already established is 32. Oh my god, it's driving me crazy. 2. And again, that's 32. But we only care about the units digit. So then, if I do 2 to the 6th, I'm just going to be multiplying 2 times 2 again, and this pattern is going to repeat over again and over and over and over again. So the interesting thing on this is, it doesn't matter what the number is, right? The possible answers are always going to be 2, 4, 8, and 6, and that pattern is going to repeat over and over and over again. So the question is, of those 4 possible answers, how many times do they go into 5? How many times do they go into that exponent? Well, 4 goes in once with a remainder of 1. Notice how 5 has a remainder of 1. Notice also how 1 also has a remainder of 1, which there's our 2. So in these problems, if this was, say, 32, or even better, let's say we had 2 to the 2002, all you'd have to do is, since there are 4 possible answers, you do the 4 and you divide that into, and let's see what the remainder is. Well, as luck would have it, it goes in evenly, and so there's a remainder of 0. When there's a remainder of 0, well, 4 divided by 4 is a remainder of 0, you get a units digit of 6. So therefore 6 will be the answer. That is a problem that shows up in a lot of middle school math competitions. Now, since my board is really acting up, I've just sort of had it. I'm going to stop this video, and hopefully I'm going to leave it, come back to it, and hopefully it's working better for the next 3.